Okay guys, hi, I'm gonna explain you about these solutions defined by integral. So if you happen to encounter some term that it's like e to the minus x squared or sine of x squared, it will be extremely hard to solve. So it will be almost impossible to solve while you're writing an exam or while you're doing homework, while you're writing your homework. And so you have to plot them in the next formula, that it's y of x is equal to y0 plus the integral of x0 x g of t, where g of t is your term, and dt. Okay, what we use t because we already use x in here, so we have to change the variable in order to make it mathematically working. So if you have here x's and then you have here x's, it is going to be a little bit confused. So let's watch an example, a very easy example. So we have dy over dx, it's equal to e to the minus x squared, and y of 2 it's equals to 6. Okay, so now if you remember by this notation, we know that our x0 is equal to 2, or y0 is equal to 6, and our g of t that is in here, it's going to be e to the minus t squared. Okay, we're just changing the variable, there is no other changing here. And now we will have that our y of x it's equal to y0, that it's 6, plus the integral of x0, that it's 2, to the x, and our g of t, that it's e minus t squared dt. Okay, so I believe that in most of schools, if you leave your homework like this or your exam like this, it will be alright, but this can be solved by the error function. So we write as ERF of x, it's equal to 2 over the square root of pi, the integral of 0 to x of e to the minus t squared dt, and our complementary error function, that is ERFC of x, it's equal to 1 minus the ERF of x, that is the same as having 2 over the square root of pi from x to the infinity and e to the minus t squared dt. Okay, so you start to look at it. Now if we plot this one in here, because we have x0 and xt, so we will have that y of x, so in here it's equal to 6 plus is equal to 6 plus square root of pi over 2, so in order to get rid of this term, and then we have the ERFC of 3 minus the ERFC of x. Okay, and we close it. So this will be also the answer for this one. I know it looks very scary, but let's see how. So the ERFC of 3 that is in here will be 2 over square root of pi of, now we change the x, so it's going to be 3 to the infinity of e to the minus t squared dt, and now it's minus 2 over square root of pi x to the infinity. And now if you remember two of the same thing, so if you remember this will be the same as having 2 over the square root of pi to the integral of, sorry, this is a 2, This is add 2. Okay, sorry. So it will be the same as having 2 to the x of e to the minus t squared of dt, and then when we multiply by this, and we get rid of this term, and then we have exactly the same as here. Okay, so and how does the error function looks like? So the error function, if we plot it, this is something widely used in probability and statistics. So the error function looks kind of like this. Okay, so is this one in here, and the complementary error function looks just like this. Okay, so we will have an asymptote here, and then we will go down here. This is the number 1, that's very important, and here we have 0. Okay, so this is just for you to know a little, and I hope you enjoyed. So see you next time.